This is an astrolabe, an ancient astronomical instrument used for many purposes. We're going to dwell on the astronomical purposes, which is the main purpose of this instrument. Its origins seem to be lost in the mists of history, possibly developed during the Greek Hellenistic period. Possibly Hipparchus had a hand in its development. In any case, what this basically is a projection of the sky, the night sky, particularly because of the stars, onto a flat plate, so you can do calculations on a flat plate instead of having a spherical astronomical device to do calculations. The front of the astrolabe is quite complicated, and it got artistically very highly decorative during the Islamic period, where they used many of its calculations and used it to determine which way to go to Mecca and what time it was for prayers. But it finally found its way into Europe during the late Middle Ages through the Pyrenees, and was very popular into the invention of more accurate clocks, and then it fell into obscurity except for astronomy history classes, where it remains a topic of great interest. We will dwell and we will talk about the different parts of the astrolabe. On the back, it's much simpler. It has some diagrams, and it has a revolving rule, which we will use to determine the zodiac date that corresponds to our current Georgian date, and also use it to determine the elevation of a particular star that we are interested in. As you can see, I've taken it apart, and on the front, the base thing is called the climate. I have no idea, but it is the projection of the night sky onto the plate. And I'll insert a diagram which maybe give you a little help on that. But in any case, you'll recognize this. It looks like the markings on my brass climate plate that I just showed you, and in fact it is. There's several prominent things that we should point out. One is the center, and this is the North Celestial Pole, Polaris in our case. But you don't see a lot of grid lines from that. You're not seeing a projection as we know the celestial sphere that we studied in class. These other circles have nothing to do with the general Polaris-centered celestial sphere. This diagram is for a person in New York City at 40 degrees from the North Celestial Pole, and right overhead would be his zenith. From his zenith in the sky, the person can imagine a grid on the sky, which has the grid latitude lines and the grid longitude lines, so that when he discovers a star there, he can relate it to this grid system. This grid system then is projected down onto this flat plate. And you can see some of these circles, because around here are the latitude circles, and these are the longitude circles that go out. So this is an accurate projection of this onto a flat plate. That's his zenith. So that this should help you when we are talking about locating stars in the sky in relation to this grid system. There's going to be a star pattern that's going to rotate around this Polaris bolt. And since it rotates on this, that's our North Star. The North Star is in the center. Directly overhead is the zenith. That's 30 degrees latitude is the zenith here. Now why 30? That's Gainesville. This specific client is for that latitude, which meant in Islamic period they often had to have 2 or 3 of these. They went north or south. Since we're going to hang around in Gainesville, we can just use this. And so this again is projection overhead, as if the lines you've looked at a globe, and it has longitudes and latitudes drawn on the globe. It is as if these lines are projected up into space into the overhead sky and then brought down here and compressed down here. There's a certain amount of distortion that is in this diagram I just showed you. So this is the 40-degree line. The 30-degree line goes right through the North Star, since we're 30 degrees elevation here, and it looks like these are classic longitudinal lines. So this gives you a projection of positions in space relative to Gainesville. Why this is important? Well, there's another thing called the REIT, and it's probably the most decorative, most striking part. And what this has on it is a sort of projection of where the stars might be. And if you look carefully, you'll see the name of a particular star. There's Sirius, for example. Altair is on here. It also has a zodiac circle, which is important because our current time has to be transferred into zodiac time. Everything on the astrolabe was sort of set on zodiac time. So this rotates around that bolt that I showed, which was the North Star. And obviously the celestial sphere does rotate around the North Star. Okay. Now, this pointer is obviously very much simpler, and we'll see the use of it later on to sort of line up the zodiac date with the time. Because I failed to mention, there was kind of an interesting here. It's like a clock. You'll see it says midnight, and then it says 12:30 o'clock, which we know is 11 p.m., like that. So there's a clock on which we will be using. Okay. Now on the back side, I'll get more specific. There is a calendar here that we're able to change the dates from our current Georgian dates into zodiac dates. So like December 31st, which we'll be using, we can convert that to Capricorn 9. And also, as you will see, this pointer has some sighting grooves, and we will use that. You would hold this thing level and you would sight the star that you're particularly interested in, okay? So you would sight this star through there, and then you would read off the degrees, because on the outside here, past the calendar, the zodiac, is the degree elevation. Here it is obviously level, and up here would be like 30 degrees. So that's how the different parts of the astrolabe work. Okay, let's actually use the astrolabe instead of talking about how would somebody use this. Let's imagine it's December 31st, you're out camping and you have your astrolabe and you've forgotten your iPhone. And you're wondering, how close is it to midnight? Should I throw the confetti in the air or have it passed it down? So we need to find out what time is it at night on this particular day. And the first thing we must do is we need to go to the back of the astrolabe, because we need to convert December 31st, our calendar, into the zodiac calendar. And to do that, along the edges here, we have the calendar and the zodiac calendar. So we can use this. I will disappear it for a second. Yes. Here's December 31st. Okay, December 31st. I'll line that up, kind of clamp it down with my finger. And when I go to this area here, I see that I was on Capricorn 9. Capricorn is divided into 30 degrees, and I was at 9 degrees. So Capricorn 9 is now our date. Here I have a close-up of that setting, and you can see on December 30th, Capricorn 9, and in fact, on this next slide, you can see I put a thread where the December 31st does come across to Capricorn 9. We can forget about the other one. Now, I've been watching the sky. I've seen my favorite star, Sirius, beginning to rise in the sky, and at this particular time, I want to find out how high it is. I would hold the astrolabe to keep it level, and I would bend down and I would sight Sirius through these two ports. And when I do that, I get about 43 degrees. This shows you where the rule crosses that outer degree markings, and there's the 40, and you count up 43 degrees. This shows where I did cross it when I was sighting Sirius. So now I know two things. I know it's Capricorn, 9 degrees, and it's Sirius, 43 degrees altitude elevation. I now will turn and use the front part. I need to find my favorite star on the reed, and here he is right here, Sirius. I need to set that pointer to a 43 degree latitude line. Now, it's difficult for you to see, but here, this says 40 degrees, this says 50 degrees, and I realize that if I put the pointer there, I'm on the 40-degree line. If I put the pointer here, I'm on a 45-degree line. So somewhere right in here, the pointer would be like 43 degrees elevation, which is, remember, that's what I had in the back. I could clamp this down so it stops. Yeah, here you can see the pointer at the cirrus is at 43 degrees. Above it's the 40-degree line, below it is the 45-degree line, and that's probably pretty close at 43 degrees. Rotating on me. And now I notice down here it says Capricorn. So I will take this, it's Capricorn 10, that's Capricorn 9. Here I have a little pointer pointing to Capricorn 9 so you can see where it's located on the zodiac circle that's on the wreath. Okay, I will line this up on Capricorn 9. Here you can see the rule that's crossing Capricorn 9 on the zodiac scale, and on the outside scale it's crossing between 23 and midnight. 23 is 11 p.m., so somewhere we are between 11 p.m. and midnight. Clamp that down, and look here. Well, let me turn it the right way up. There's midnight. That's 11 o'clock. Capricorn 9. I'm on beam about 11. Here I've moved the rule aside, and the pointer points where the rule crossed. You see it crossed between 23 and midnight. There is 12 ticks between that, and each tick is 4 minutes, and we're at 6, so 6 times 4 is 12, so it's 11:24, and we haven't missed midnight. 1:30, close. I haven't missed New Year's Day. So this let me find out that I was close to midnight, but before midnight, by using the elevation of Sirius and the front plate here, like that. This, by the way, would be solar time. That means that my time here is different than somebody who's a little more east or a little more west, rather than the time zones we normally have. But that shows you how you can use the combination of the zodiac calendar here, the elevation of Sirius, the location of Sirius on this rete, and then the pointer of Sirius on the climate at 43 degrees, and then using this to go to the zodiac Capricorn that you had, and you can find the midnight. Obviously, it'd be a lot easier on your iPhone, but it didn't take me more than a few minutes to find out. I'm glad I haven't thrown the confetti into the sky yet. That is one of the uses. Obviously, it can be used during the day when you can sight the sun, which of course has certain hazards to it. There's many other uses for this, but I thought it'd be interesting to use this as an example of what it could be used for.